All right, let's take a look at the practice test, where the instructions were asked to sketch the graph of each and state the foci and vertices. All right, let's just do a review before we get into any problems. If you're struggling with this, it's usually because the formulas are changing around based on if you have a horizontal hyperbola, so one that opens to the left and to the right, or a vertical hyperbola, so one that opens up and down. So we're looking at x squared over a squared minus y squared over b squared equals 1. So this is a horizontal hyperbola with its center at the origin, or the point 0, 0. So when we go back to the lesson, we talked about the fact that a, which is the principal square root of this, so if I take the square root of a squared, I know by definition this is the absolute value of a, but because we're going to be talking about a distance here, this is just going to be a. So this a represents the distance from the center to each vertex. So from 0, 0, which is the center, to this vertex right here, that's the distance of a units. So this would be a, 0, and then from 0, 0, I'm going to go to the left by a units. So this is negative a, 0, so that's another vertex. When you think about using these vertices as endpoints, you're going to create a line segment, which is called the transverse axis. So if the transverse axis is horizontal, you're going to have a horizontal hyperbola, meaning this guy's going to open to the left and to the right. And the way you know that is because the vertices are always going to be on your hyperbola. The co-vertices are not going to be on the hyperbola. Those are going to be involved with the asymptotes and the fundamental rectangle. When you think about the co-vertices, so you have 0, b and 0, negative b, well, that's coming from just taking this b squared right here and just take the principal square root of that. So again, that's the absolute value of b, but because this is a distance, just get rid of that and just say it's b. Well, you're going to go from the center, b units up, and then you're going to go b units down. So you can have 0, b and 0, negative b. So this creates, if you use these endpoints right here, a conjugate axis, which is perpendicular to the transverse axis. So this is the line segment with the co-vertices as its endpoints. Then when we talk about the foci, so you can have c, 0 and negative c, 0, those are going to lie on the same line that contains the transverse axis. The line that contains the transverse axis would be y equals 0, or the x-axis, again, because the center's at the origin. So in this particular case, your foci are going to be on the x-axis. So c, 0 and negative c, 0, and you can define c to be the distance from the center to each focus. So c units to the right, and then c units to the left. Additionally, we have our fundamental rectangle, and we have our asymptotes. And that's coming from this relationship with a and b. So if we think about this point right here, this a, b, where does that come from? Well, I know that this right here is a units to the right, and I know this is b units up. So if I combine those, I go a units to the right and b units up, I get this point, which is a, b. If I take this right here and I go a units to the left and b units up, I get negative a, b. If I take and go a units to the left and b units down, I get negative a, negative b. And then if I go a units to the right and b units down, I get a, negative b. So those are the endpoints of what we call the fundamental rectangle. And if you extend the diagonals of this guy, you're going to get your asymptotes. You could also get this using point slope form. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, we know that a point is going to be 0, 0. So you could plug in a 0 here, and you could plug in a 0 here, just to keep things simple. So that collapses this down, and that collapses this down. So now you have y equals mx. Well, what is the slope? Well, you could use the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is b, and then y sub 1 would be 0. And then you could say x sub 2 is a, and x sub 1 is 0. So this is a minus 0. And this turns into b over a. So that is your slope. So this becomes y equals b over a times x. And that's basically it in terms of deriving that. For the other one, you could use a similar process. This is going to be a negatively sloped line, so you're going to get y equals negative b over a times x. So that's going to be for this guy right here. So just a quick recap. So for this form right here, we have a center of 0, 0, the vertices plus or minus a, 0, the co-vertices 0, plus or minus b, the foci plus or minus c, 0, the asymptotes y equals plus or minus b over a times x, the endpoints of the fundamental rectangle, again, a, b, negative a, b, a, negative b, negative a, negative b. The transverse axis is horizontal, meaning in this particular case, it lies on the x-axis. The conjugate axis is vertical. In this particular case, it lies on the y-axis. Now, this is the other thing I want to cover. This causes a lot of confusion. So where does this c squared equals a squared plus b squared, or rearranged, b squared equals c squared minus a squared? Where does that come from? Well, when you're deriving this guy, that substitution is actually made for convenience, but you can actually show this just using a right triangle and the Pythagorean theorem. So the length, again, from the center to each focus is c. If you were to flip this up like this and create a right triangle, you're going to see that this right here for the hypotenuse of the right triangle you're forming, the length there is c. This, of course, is a, and this is b. So we know the relationship in a right triangle, c squared equals a squared plus b squared. All right, so similarly, this is going to be for a vertical hyperbola, one that opens up and down with the center at the origin. So now we have y squared over a squared. So here a squared is underneath y squared. So this is what caused a lot of confusion. Then minus x squared over b squared is equal to 1. What is a? A is the distance from the center to each vertex. So from 0, 0, I'm traveling up by a units to 0, a. So that's a vertex. Let me actually use a different color there so it shows up better. And then I'm going to travel from the center down by a units. So this is 0, negative a. Your transverse axis here, again, is going to be vertical. So it's a line segment with these vertices as the endpoints. Then, when you think about the conjugate axis, well, again, it's perpendicular to that, and you've got the co-vertices as the endpoints. So negative b comma 0 and b comma 0. So this guy right here, so that's going to be horizontal in this case. And again, we know that b is the distance from the center to each co-vertex. So I'm going b units to the right, I get b comma 0. I'm going b units to the left, I get negative b comma 0. Remember that if the transverse axis is vertical, this guy's opening up and down because the vertices, again, are on the hyperbola. That's how you remember that. And the line that contains the transverse axis, in this case, that would be the y-axis or the line x equals 0, that's where your foci are going to lie. So this is going to be 0, c, and this is going to be 0, negative c, again, because the distance from this right here, this 0, 0 or the center to each focus is going to be c units. C units up and then c units down. Now, if you think about forming a right triangle here, again, it's going to be slightly different because the length of this right here is now going to be b, and the length of this right here is now going to be a. So the slope of this guy is going to be rise over run a over b. So when you think about this right here, that's why you get y equals a over b times x. And then if you looked at this one going down like this, again, it's just a negatively sloped line, so y equals negative a over b times x. And if you form this right triangle, again, this is going to be your c right here. So you still get c squared equals a squared plus b squared, or again, you can rearrange that to say b squared equals c squared minus a squared. In terms of your fundamental rectangle, because things are switched around, so starting at the center, I'm going b units to the right and a units up. So that's b comma a. I'm going b units to the left and a units up. So that's negative b comma a. I'm going b units to the left and a units down. That's negative b comma negative a. And I'm going b units to the right and a units down. So that's b comma negative a. So just to recap, again, for y squared over a squared minus x squared over b squared equals 1, we have our center at the origin, which is 0, 0. The vertices are now 0, plus or minus a. Your co-vertices are plus or minus b, 0. Your foci are 0, plus or minus c. Your asymptotes are y equals plus or minus a over b, x. And then your endpoints of the fundamental rectangle, b, a, negative b, a, b, negative a, negative b, negative a. The transverse axis is vertical, so it lies on the y-axis in this case. The conjugate axis is horizontal, so it lies on the x-axis in this case. All right, let's talk about shifting things around now. So let's say you have some h, k that's not at the origin. So if h and k are positive real numbers, where h is greater than 0 and k is greater than 0, if x is replaced with x minus h, you're going to shift the graph h units right. Again, when you think about something wrapped in parentheses, you're always undoing things. So if it's x minus h, you're going to go to the right by h units. If it's x is replaced with x plus h, you're going to shift the graph h units left, just undoing things. Y is replaced with y minus k, you're going to shift the graph k units up. And then y is replaced with y plus k, shift the graph k units down. So you can use this, and I'm going to put this as a reference in each problem. So if your transverse axis is horizontal, remember that means we're opening to the left and opening to the right, well, your equation is x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1, and your center's at h, k. So all I did was I replaced x with x minus h and y with y minus k in the formula that we talked about earlier. And what that is going to do is that your vertices now are going to be h minus a, k, and then h plus a, k. Because you're starting at your x coordinate from the center, which is h, and you're moving to the left by a units and to the right by a units, you're not going to change at all in terms of your y coordinate from the center, so it's just going to stay as k. For the co-vertices, it's h, that's not going to change, comma k minus b, and then h, k plus b. So in other words, from the center, you're traveling b units down and b units up. And then for the foci, it's going to be h minus c, k, and then h plus c, k. From the center, you're traveling c units to the left and c units right. So just to show you this real quick, we have a lot of stuff involved here, but essentially if you look at your center, which is h, k, let me fill that in right there. If you think about this guy opening to the left and to the right, well, this is a vertex right here. So I'm going from h, k to h plus a, k. So I'm going a units to the right. And then I'm going to go a units to the left. So this guy right here is h minus a, k. So this right here is the transverse axis. Again, if it's horizontal, you're opening to the left and to the right. Then similarly, if you think about this point right here, and this point right here, those are your foci. So I'm going from the center, C units to the right, and I'm going from the center, C units to the left. So I have H plus C comma K, and then H minus C comma K. If I think about my co-vertices here, well, I'm going up by B units and down by B units from the center. So this is H comma K plus B, this is H comma K minus B, and again, if I use those as the endpoints, this axis right here is called the conjugate axis. In this case, it's going to be vertical. I'll talk about the slope and the endpoints for the fundamental rectangle in a moment. I have that in a different table because it's just so much information. Let's just go through where the transverse axis is vertical, and then I'll touch on that. So here you're replacing your y with y minus k and your x with x minus h. So you have y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. Center is still h comma k. Transverse axis again is vertical. And now from your center, you're moving up by a units and down by a units to get to your vertices. So h comma k minus a, h comma k plus a. For the co-vertices, you're moving to the left by b units and to the right by b units. So h minus b comma k, and then h plus b comma k. And then for the foci, you're moving down by c units and up by c units. So h comma k minus c, and then h comma k plus c. So this is the case where you have your transverse axis that is going to be vertical. So here is your center, h comma k. Here is a vertex, which is h comma k plus a. So I traveled a units up to get to the vertex. Then I'm going to travel a units down to get to the other vertex. So that's h comma k minus a. So this right here, again, is going to be your transverse axis with those vertices as the endpoints. Then if I think about the conjugate axis, you're going to have these co-vertices as the endpoints. So remember, you're traveling from the center, b units to the left, so this is h minus b comma k, and then b units to the right, so this is h plus b comma k. So because the transverse axis is vertical, again, from the center, I'm traveling c units up to get to this focus right here, so h comma k plus c, and then c units down to get to this focus right here, which is h comma k minus c. All right, let's talk about the fundamental rectangle in each case. In the situation where it's a horizontal hyperbola, from the center, you're going a units to the right and b units up. So this is h plus a comma k plus b. From the center, you're going a units to the left and b units up. So h minus a comma k plus b. From the center, you're going a units to the right and b units down. So it's h plus a comma k minus b. From the center, you're going a units to the left and b units down. So h minus a comma k minus b. In terms of the asymptotes, remember that the slope was b over a. So that's going to be the same. Let me actually go up here and I'll derive this one right here. So where does this y equals b over a times the quantity x minus h plus k come from? Well, remember that h comma k is going to be a point on this asymptote right here. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. Well, we know the slope, again, rise over run, is going to be b over a. So you can put that in right there. And you could use the slope formula if you wanted to use this point right here and this point right here. I'll let you plug that in on your own, but you're going to see that it's b over a. You can also just use rise over run. So this is b right here. This is a right here. So that's a quicker way to do it. So b over a is your slope. Now, in terms of your point, again, y sub 1, I'm going to replace that with k. And my x sub 1, I'm just going to replace that with h. So you would get y is equal to, add k to both sides, b over a times the quantity x minus h, and then plus k. And then this one right here, where it's negative, that's just because it's a negatively sloped line. Again, it's just as easy to get that one. So that's where your asymptotes are coming from. Now, in terms of the asymptotes here and the fundamental rectangle for this one, so from the center, you're just going b units to the right and a units up. So that's h plus b comma k plus a. From the center, you're going b units to the left and a units up. So h minus b comma k plus a. From the center, you're going b units to the left and a units down. So h minus b comma k minus a. And then from the center, you're going b units to the right and a units down. So h plus b comma k minus a. In terms of the asymptotes, the slope is the only thing that's going to change. Everything else is the same. If you look at your rise now, again, that's going to be a, and your run is b. So that's why it's a over b for the slope. All right, let's take a look at the first problem. So we have the quantity y plus 1 squared over 16 minus the quantity x minus 2 squared over 9 is equal to 1. So the first thing you're going to do for this problem is just match the form. So do we have a transverse axis that is vertical, or do we have a transverse axis that is horizontal? In this case, because the minus is in front of where the x is, you're going to say that the transverse axis is vertical. So you can just say it's a vertical hyperbola. And so we're going to match with this form right here. So this is going to allow us to get all the information we need to sketch the graph. So just going through here, you want your h comma k, which is the center. So if you look at the h, that's going to be 2. So notice this minus matches with this minus, so h is equal to 2. Then when you think about the k, so that's not as straightforward. So here's k right here. Do I just take 1 as k there? No, because this doesn't match perfectly. This is a minus, but this is a plus. So you'd have to rewrite this as y minus a negative 1, and then you'd have a minus and a minus. And so you want this to be a negative 1 here for k. It's not positive 1. Again, that's a common mistake. Then when we look at a squared, that's going to be 16. So you're just matching up those denominators and taking that. And then when we look at our b squared, that's going to be 9. Again, we're just matching up those denominators. Now we're going to need c squared here, and that's coming from our relationship where we say it's equal to a squared plus b squared. Well, a squared is 16, b squared is 9, so 16 plus 9 is 25, so c squared is 25. When you find a, b, and c, remember that you just want the principal square root only. A is the distance from the center to each vertex, b is the distance from the center to each covertex, and c is the distance from the center to each focus. So a is the principal square root of 16, so 4. B is the principal square root of 9, so 3. And c is the principal square root of 25, which is 5. So coming down here with our table, our center is at h comma k. So the center is going to be at 2 comma negative 1. Again, h is 2, k is negative 1. We're working with this guy right here on the bottom, so the bottom row here, which is for a transverse axis that is vertical. So the vertices, again, it's h comma k minus a, and then h comma k plus a. The covertices, h minus b comma k, h plus b comma k, and the foci, h comma k minus c, and then h comma k plus c. So again, I already wrote everything out. So your vertices, again, if you plug in, you're going to get 2 comma negative 5, and then 2 comma 3. Covertices, you're going to get negative 1 comma negative 1, and then 5 comma negative 1. And then your foci, you're going to get 2 comma negative 6, and then 2 comma 4. In terms of your asymptotes and the endpoints for the fundamental rectangle, again, we're just matching things up here. You're going to be in this second row. So the asymptotes, y equals plus or minus, again, this slope right here is a over b times the quantity x minus h plus k. So we know h is 2, k is negative 1, a is 4, and b is 3. So you get y equals plus or minus 4/3 times the quantity x minus 2, then minus 1. So you're going to split that up. So you get y equals 4/3 times the quantity x minus 2 minus 1. If you simplify, you get y equals 4/3 x minus 11/3. Then you get y equals negative 4/3 times the quantity x minus 2 minus 1. If you simplify, you're going to get y equals negative 4/3 x plus 5/3. In terms of the endpoints for the fundamental rectangle, again, just plugging in, you're going to get 5 comma 3, negative 1 comma 3, 5 comma negative 5, and then negative 1 comma negative 5. All right, so let's come down here and look at the graph. So I'm just going to tell you in advance, I left you a Desmos link for everything today. So you can just click on that if you want to follow more closely. So everything on this graph, we already found using the formulas from our tables. So if you want to pause the video here, get some graph paper and sketch the graph on your own, you can do that. Of course, you can always just look at the Desmos link if you want to just verify things that way. But what I'm going to do for this problem is go real slow, and I'm going to show you how you can get all this stuff and sketch the graph without any formulas. So first off, I would take this guy, if I got this problem, and I would rewrite it. So I would say this is y minus a negative 1 quantity squared, and this is over, you could put 16, or it's probably easier here just for clarity to write this as 4 squared. Then minus, we're going to put x minus 2 quantity squared over, instead of 9, let's write 3 squared, and this equals 1. So I know that I'm going to match this up to my formula where the transverse axis is vertical and the center is at h comma k. So this is y minus k quantity squared over a squared, and then minus, this is x minus h quantity squared over b squared, and this equals 1. If you can just remember this, you're pretty much going to be good to go. So you can match things up. Remember, this is a minus and this is a minus, so k is going to be negative 1. This is a minus and this is a minus, so h is going to be 2. So my h is equal to 2, and my k is equal to negative 1. So the center is at h comma k, so 2 comma negative 1. So that's going to give me this point right here. So that's what you would start with, is getting the center. Once you know the center, I would get the vertices and the covertices. And again, that goes back to the definition of the distance from the center to each vertex is a, and the distance from the center to each covertex is b. Well, here, a is the principal square root of 16, which is 4. That's why I wrote it like this. So you could just take this number here. So a is equal to 4. And then b is equal to, again, the principal square root of 9. So that's why I wrote it this way. So that's going to be 3. Again, because we know the transverse axis is going to be vertical, we know that going from the center to each vertex is going to be a vertical movement. So I'm going up by 4 units from the center, and I'm going down by 4 units from the center. So if I start at 2 comma negative 1 and I go up by 4 units, well, the x coordinate's not going to change. So when I get up here, it's still going to be a 2. But the y coordinate, I'm going to go negative 1 plus 4, that's positive 3. So this right here is 2 comma 3. So that's a vertex. Then I'm going to go down by 4 units, and I'm going to get to 2 comma negative 5. Again, the x coordinate does not change. You go negative 1 minus 4, that's negative 5. If you want to draw the transverse axis, sometimes they'll ask you to do that, it's just going to be the line segment where the vertices are the endpoints. So the endpoints are 2 comma 3, and this 2 comma negative 5. All right, I'm just going to erase that. Let me put my center back in. I'm just going to color that back in. All right, in terms of the covertices, remember that if the transverse axis is vertical, the conjugate axis is going to be horizontal, because the transverse axis is perpendicular to the conjugate axis. So we're going to be moving horizontally here. And again, we go back to b is equal to 3. Well, that's the distance from the center to each covertex. So I'm going to go from 2, 1 to the right 3 units, and I'm going to end up at 5, 1. So the x-coordinate of 2, I add 3 to that, I get an x-coordinate of 5. The y-coordinate is going to stay the same. It's still going to be -1. Then for this one, I'm going to go 3 units to the left. So 2 minus 3 would be -1. So that's my x-coordinate. And then the y-coordinate is still going to be -1 because I'm just moving horizontally. So this point right here would be -1, -1. Again, sometimes they'll ask you to draw in the conjugate axis. So if they do, it's just the line segment with the covertices as its endpoints. All right, let's get rid of that. And now let's talk about the foci. So this is the one that causes a little bit of confusion, especially if you watch where people derive it and they end up with this formula, which is c squared is equal to a squared plus b squared. Well, it's really easy to look at this guy with an example and see that this is going to be the case. First off, if you just use the distance formula to find the distance between this point right here, which is 2, -1, and this point right here, which is 5, 3. Let me actually erase d real quick. And I'm going to write 2, -1, and I'm going to write 5, 3. And I'm just going to label this so this is clear. So this is x sub 1, y sub 1. This is x sub 2 and y sub 2. And if you plug into the distance formula, let me come down here so I have some room. You have the distance between these 2 points is the square root of, you have the quantity x sub 2 minus x sub 1 squared, and then plus the quantity y sub 2 minus y sub 1 squared. Well, x sub 2 is 5, and x sub 1 is going to be 2. So this is 5 minus 2 here. And then y sub 2 is going to be 3. And then y sub 1 is going to be -1. Minus a -1 is +1. So this is equal to the square root of 5 minus 2 is 3. So you would get 3 squared, which is 9, plus 3 plus 1 is 4. 4 squared is 16. So this would be equal to the square root of 9 plus 16 is 25, which equals 5. So the distance between this point 2, -1 and 5, 3, we've just established with the distance formula that it's 5. Now let me show you, we'll just erase this. We'll do this the long way, just using the Pythagorean theorem, and then we'll match that up with the C value and going from the center up by 5 units. Let me come back up here. We're going to erase this, and I'm going to draw in a right triangle. So let me get a ruler here. Let me draw that, and let me draw in that, and let me draw this in right here. Okay, so not perfect, but this right here is going to be our C. This right here is going to be our B, and this right here is going to be our A. So we know that because we just went through and found the center, this covertex, and we found this vertex. Now, if I move from this guy to this guy, I already know that it's a distance of 3 units, right? So I could say the length of this side is 3. Again, coming from the principal square root of this guy right here, we know that b is equal to 3. That's where that's coming from. This right here, you could just get it from this right here, because all it is this is going from 2, -1 up to 2, 3. Well, here we're going from 5, -1 up to 5, 3. So the vertical distance there is going to be the same as this one right here, right? So we did that one earlier. This length right here is going to be a, and again, that's the principal square root of 16, which is 4. So if this is 3 and this is 4, we know from the Pythagorean theorem, this is 5. And again, we just confirm that by using our distance formula. You can always plug in if you need to. Again, you can just say that c squared is equal to, let's go 4 squared plus 3 squared, which is equal to, this is 16 plus 9, which is 25. So c squared is 25. That means c is equal to 5. Let me actually put a 90-degree symbol in there, just so that's clear. So this is our right triangle. And we know that c is equal to 5 at this point. And again, because the transverse axis is vertical, that means I'm going from the center, let me color that back in, up 5 units, and from the center down 5 units to get to my foci. So if I go from 2, -1 up 5 units, I'm going to be at 2, 4. The x-coordinate does not change, it's still 2. The y-coordinate, you just do -1 plus 5, that's 4. To go down here, I'm staying with my x-coordinate of 2. My y-coordinate, -1 minus 5, that's -6. So I get 2, -6. So those are your foci. Again, when you look at this right here, that's going to be 5. And that exactly matches this right here. So this is 5 as well. So just keep that in mind when you're studying this. All right, let me get rid of this. And now let's talk about the endpoints of the fundamental rectangle and also the asymptotes. In terms of the fundamental rectangle, all you're really doing is you're saying, well, to get from the center to each covertex, I have a horizontal movement of 3 units. And to get from the center to each vertex, I have a vertical movement of 4 units. So you're just combining all the possibilities. So from the center, I'm going to go 3 units to the right and 4 units up, and I'm going to end up at this 5, 3. From the center, I'm going to go 3 units to the left and 4 units up, and I'm going to end up at -1, 3. From the center, I'm going to go 3 units to the left and 4 units down. I'm going to end up at -1, -5. And then lastly, from the center, I'm going to go 3 units to the right and 4 units down, and I'm going to end up at 5, -5. So those are the endpoints for the fundamental rectangle. Sometimes your teacher will ask you to draw it, sometimes they don't. Remember that if you extend the diagonals here, you're going to get your asymptotes. But you can also come up with them just using the point slope form. So that is y minus y sub 1 is equal to m times the quantity x minus x sub 1. So the point you're going to use is going to be the center, so your h comma k. So let's go y minus, your y sub 1 would be your k value, so that's -1, is equal to m times the quantity x minus your x sub 1 would be your h value, so that's 2. Now, how do we get the slope? Again, you're just going to do your a over b in this case, which is 4 over 3. Now, if you don't know that, again, you can always do rise over run. You just go back to this right here. This is your run, so we know that this right here is going to be 3, and this is your rise, so this right here is 4. So the slope here is going to be, again, rise over run, which is 4 thirds. Now you can always use the slope formula if that's too confusing for you. You can plug in using this point and this point right here. And let's just do that real quick just for completeness. So you have 5, 3, and then you have 2, -1. So let's say this is x sub 1, and this is y sub 1, and this is x sub 2, and this is y sub 2. So if you plug into the slope formula, let me slide down here a little bit, you have m, and that's a lowercase m, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, y sub 2 is -1. And y sub 1 is 3. X sub 2 is +2. And x sub 1 is going to be 5. So -1 minus 3, that is going to be -4. And this is over 2 minus 5, that is -3. Well, negative over negative is positive, so this is +4 thirds. And let me actually fix that real quick. So that matches what we got there just using our rise over run. So coming back, all you have to do is solve this for y. So this is y plus 1 is equal to 4 thirds times the quantity x minus 2. You can distribute that. So this is 4 thirds x, and then minus 4 thirds times 2 would be 8 thirds, and then just subtract 1 away from each side. So I'll just erase it from over here. And you could write this as 3 over 3. And we saw these steps earlier. So this is just y is equal to 4 thirds x, and then -8 thirds minus 3 thirds. That would be -11 thirds. So that's going to be where this guy is coming from. That's the equation of this asymptote. If you wanted the equation of the other one, which is this guy right here, it's negatively sloped. Well, now the slope here, you're just going to change it from 4 thirds to -4 thirds. And again, you could use this point right here and this point right here and plug into the slope formula like I just did, and you would prove that. You could also do the rise over the run. But if you simplify this one, again, you get y plus 1 is equal to, this is -4 thirds x, and then negative times negative is positive. 4 thirds times 2 would be 8 thirds. And let's subtract 1 away from each side. So I'm going to go -1 over here and erase this from over here. And I'm going to write this as 3 thirds. And so you get y is equal to -4 thirds x. And then 8 thirds minus 3 thirds is 5 thirds. So plus 5 thirds. So that's where this guy is coming from right there. So y equals -4 thirds x plus 5 thirds. All right, so that's pretty much everything. And obviously it's way quicker if you memorize those formulas from the tables that I showed you, but sometimes you forget them, and it's good to know the definitions in case you're in a pinch. In terms of hand sketching the graph, pretty much I would make sure that I identify the vertices and then just make something to where each branch here approaches the asymptotes but does not touch. That's all you have to do. It doesn't have to be perfect. So this one down here will just approach but not touch. And I know I'm not doing this perfectly, but again, you can always look at Desmos if you want something that's computer generated and perfect. All right, for problem 2, we have x minus 1 quantity squared over 9 minus y plus 2 quantity squared over 4 is equal to 1. So just matching things up so we can use our formulas. This guy is going to be a horizontal hyperbola, meaning the transverse axis is horizontal. So when we think about the minus right here, notice how it's in front of where y is. So that's how you know this is horizontal. All right, so let's get our center, which is h comma k. So this right here is a minus and this is a minus. So h is going to be 1. And then when we think about our k, well, this is a minus and this is a plus. So you want to rewrite that to y minus a -2. So this right here for k would be -2. Then when we think about our a squared, well, here's a squared, that's going to be 9. When we think about our b squared, that's going to be 4. So then c squared is coming from a squared plus b squared. So that's 9 plus 4, which is 13. So a is 3, B is 2, and C is the principal square root of 13. All right, so coming down here, now we're going to use the first row. So we're going to say that the center, again, is h comma k. So h is 1, k is -2. So that's going to be 1 comma -2. And again, you can just plug into this formula here for the vertices, the co-vertices, and the foci. So I have all this done for us. So the vertices, that's going to be -2 comma -2, and then 4 comma -2. The co-vertices, you're going to have 1 comma -4, and then 1 comma 0. And then the foci, you're going to have 1 minus the square root of 13 comma -2, and then 1 plus the square root of 13 comma -2. So this right here on the graph, it's approximated. It's about -2.606. This on the graph is also approximated. So I'm going to say it's about 4.606. All right, let's take a look at finding the asymptotes and the endpoints for the fundamental rectangle. So we're going to be working with this top row right here. So we're going to need this guy right here and this guy right here. All right, so coming down here, I just pre-wrote everything to make it faster. So the asymptotes, you're going to have y equals plus or minus b over a times the quantity x minus h and then plus k. So h here is equal to 1. K here is equal to -2, A here is equal to 3, and B here is equal to 2. So plugging in, we get y equals plus or minus 2/3 times the quantity, x minus 1, and then we have -2. So for the first scenario, where your slope is positive 2/3, you have y equals 2/3 times the quantity x minus 1, then -2. If you simplify, you're going to get y equals 2/3 x minus 8/3. For the second scenario, where your slope is -2/3, y equals -2/3 times the quantity x minus 1, and then you have -2. If you simplify, you get y equals -2/3 x minus 4/3. In terms of the endpoints for the fundamental rectangle, again, you're just plugging in. You're going to get 4 comma 0, -2 comma 0, 4 comma -4, and -2 comma -4. So coming down to the graph, I will take my time again on this one. I'm not going to take as much time as I did on the first one, so I won't be going into as much detail, but we will take some time on this one, and then we'll pick up the pace on the next ones. I'm going to rewrite this. So x minus 1 quantity squared over, instead of 9, you can write 3 squared, just for clarity. Then minus, we're going to have y. Instead of plus 2, let's write minus a -2, just so we match the form. So this is a quantity squared over. Instead of 4, let's write 2 squared. And of course, this equals 1. Let me actually fix that. So if you get something like this, and again, you don't have any information yet, and you need to sketch the graph, always think about the form that you want to match this to. So we know this is a horizontal hyperbola because the minus is in front of where the y is. If the minus is in front of where the x is, then we know it's a vertical hyperbola. That's how you remember it. So this just becomes x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. So this is just something you have to memorize. So we know we can extract the information that h is 1, k is -2, a is going to be 3, and you could say a squared is 3 squared, which is 9, and then b is going to be 2, or b squared is 4. Now I can erase that. Again, we've already written this stuff down before, so let's just write that out real quick. So h is 1, k is -2, a is going to be 3, b is going to be 2. We previously found that c is equal to the square root of 13. Again, that comes from that relationship where we say c squared is equal to a squared plus b squared. Well, a squared is 9, b squared is 4, 9 plus 4 is 13. So c squared is 13. That means that c is the principal square root of 13. So that's where that's coming from. When we look at our coordinate plane, the first thing you'd want to do is plot the center. So that's h comma k. That is 1 comma -2. Then you want to start working on your vertices. So use the definition. A is the distance from the center to each vertex. In this case, that's 3. Am I moving vertically or am I moving horizontally? This is a horizontal hyperbola. The transverse axis will be horizontal. So I'm going to move to the right by 3 units from the center. So that's going to put me at 4 comma -2. So that's a vertex. And I'm going to move to the left by 3 units from the center. So that's going to be a vertex. That's going to be -2 comma -2. Now, in some cases, the teacher will actually ask you to sketch the transverse axis and label it. So I'm just going to draw it in real quick, and then I'll erase it. But if you need to draw it in for your class, that's how you would do it. So the endpoints are the vertices. I'm just going to erase that, and actually I'm going to erase that. So now I'm going to work on the co-vertices. For that, we use b. So b is the distance from the center to each co-vertex. In this case, it's 2. If the transverse axis is horizontal, we just drew it, the conjugate axis is perpendicular to that, so it's going to be vertical. So that means I'm moving 2 units up from the center. So I'm going to go to this point right here, which is 1 comma 0, and I'm going to move 2 units down from the center. So I'm going to be at this point right here, which is 1 comma -4. So those are your co-vertices. You might be asked to sketch this in. That would be your conjugate axis. Sometimes you have to draw it and label it. So the co-vertices are the endpoints there. When we think about the foci, if you have a c that's equal to the square root of 13, well, I'm moving to the right by the square root of 13, from the center, and to the left by the square root of 13 from the center. So that's going to give me this point right here, which is 1 plus the square root of 13, which we approximated to 4.606, and then comma -2. And if I go to the left, again by the square root of 13, this would be 1 minus the square root of 13, which we approximated to -2.606, comma -2. So those are going to be your foci. Now you would work on your fundamental rectangle. Let me actually get rid of this. We would really just need A and B here. Remember that in this particular case, A is involved with horizontal movement and B is involved with vertical movement. So just do the easy one. You're just going to start right here at the center and you're going to say, I'm going to go A units to the right and B units up. Again, what is horizontal? It's A. What is vertical? It's B. So that's how you remember that. So if I go A units to the right and B units up, I'm going to get to that point right there, which is H plus A, comma, K plus B. You can just say that I'm moving 3 units to the right, so 1 plus 3 is 4, and then 2 units up, so -2 plus 2 is 0. So you get to that 4, 0. So similarly, if I go 3 units to the left and 2 units up, I'm going to be at -2, 0. If I move 3 units to the left and 2 units down, I'm going to be at -2, -4. If I move 3 units to the right and 2 units down, I'm going to be at 4, -4. Now, in terms of getting the asymptotes, once you have the endpoints for the fundamental rectangle, you can just extend the diagonals and you have your asymptotes. So if you're in a rush, it might be faster to do it that way. It just depends. Sometimes the teacher wants everything. And in that case, then you have to label your asymptotes and put the equation for each. And again, you can always use point slope form if you can't remember. So I'll just do that one more time. So y minus y sub 1 is equal to m times the quantity x minus x sub 1. And all you have to do is rise over run. If you can't remember that, then just circle this point and circle this point. So those are 2 points on this asymptote right here that is positively sloped. If you plug into the slope formula, you're going to end up with positive 2/3. Again, I'll just do that for completeness real quick. I don't want anybody to be lost. So this, let's label it as x sub 1. This is y sub 1. This is x sub 2, and this is y sub 2. So your slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is going to be -2, and y sub 1 is 0. And then x sub 2 is 1, and x sub 1 is 4. So here you have -2 minus 0, which is -2, over 1 minus 4, which is -3. Negative over negative is positive, so this is 2/3. The quick way to do that is just to do rise over run. So this right here is your run, and again, that corresponds to A in this case, so we know that's 3. This right here is your rise, that corresponds to B in this case, so we know that's 2. So the quick way to do that is rise over run, it's 2/3. But if you get confused by that, you can just use the slope formula. It's really no problem, it just takes a little bit longer. So you can replace this with 2/3. And then for your point, your x sub 1 comma y sub 1, again, you can just use this point right here. So that's your center, your h comma k. So you have y minus, your y sub 1 is -2, minus the -2 is +2. And that equals 2/3 times the quantity x minus your x sub 1 is going to be 1. So this becomes y is equal to, I'm going to distribute this, so 2/3 x and then minus 2/3. And I'm going to subtract 2 away from each side. So -2. And again, if you watched what I did earlier, you saw that I came up with this. And this is y is equal to 2/3 x. And then you could write this as 6/3. And -2/3 minus 6/3 is -8/3. So that is how you get the equation of this asymptote right here. For the other one, you're pretty much doing the same process. I'll let you do that one on your own. You saw me do it earlier before we got to this graph. So you would produce this line right here. This is the one that's negatively sloped. So it's this one. So y equals -2/3 x minus 4/3. So once you have all that stuff, again, based on your teacher, they might want everything. They might just want the vertices and the asymptotes and a basic sketch. It's really up to them. So I'm just going to put a point there for my vertex and another one for that one. And I'm just going to draw each branch to where it approaches, but does not touch those asymptotes. Same thing over here. So it's going to be drawn to where it approaches, but does not touch those asymptotes. All right, for the rest of the problems, we're just going to change up the instructions. So we're going to write each in standard form and then sketch the graph. All right, for problem 3, we are given -4x squared plus 9y squared minus 16x minus 126y minus 151 is equal to 0. So if you want to put this into standard form, you're going to complete the square twice. You're going to group your x guys together and your y guys together. So you're going to write this as -4x squared minus 16x. So you have this guy, and then you're going to put plus 9y squared minus 126y. That's coming from this guy. And then you could just have your minus 151 is equal to 0. So then what you're going to do is factor out the coefficient of the squared variable, because if we complete the square, we want that to be 1. So you pull this out, you get negative 4 times the quantity x squared plus 4x plus 9 times the quantity y squared minus 14y minus 151 is equal to 0. So just continuing, now we're going to complete the square. Remember that you're taking the coefficient of your variable raised to the first power. So in this case, it's going to be 4. In this case, it's going to be negative 14. You're going to cut it in half, and then you're going to square it. So when I cut 4 in half, I get 2. And if I square that, I'm back to 4. So this is 2 squared, which equals 4. So I'm going to add 4 and then subtract 4 away inside the parentheses. Remember, this right here is just me adding 0. So I haven't done anything illegal. When I think about negative 14, if I multiply that by half, I'm going to get negative 7. And if I square that, I get positive 49. So you see that I added 49 and subtracted 49 away inside the parentheses. So the key thing here, and where people often make a mistake, is they just drop the parentheses or they close it down without thinking about what's going on. This negative 4 is multiplying each guy here inside the parentheses. This 9 here is multiplying each guy inside the parentheses. So if you want to close the parentheses down, so to right here, you need to distribute the negative 4 to the negative 4. And then similarly, this 9 needs to be distributed to the negative 49. So the way you're going to do this is you're going to say negative 4 times negative 4 is positive 16. That's where that's coming from. And then 9 times negative 49 is negative 441. Add 16, negative 441, and negative 151, and that's going to give you negative 576. So that gives you that form right there. Add 576 to both sides, and you have this right here. And then we're just going to factor. So x squared plus 4x plus 4, this factors into x plus 2 quantity squared. Again, always think about when you cut this in half, what did you have? 4 times a half is 2, so this is x plus 2 quantity squared. When you cut this in half, this negative 14, what did you get? You got negative 7, so that means when you factor this y squared minus 14y plus 49, you have y minus 7 there, quantity squared. So we end up with negative 4 times the quantity x plus 2 squared plus 9 times the quantity y minus 7 squared equals 576. We know with a hyperbola, we want the right side to be 1, so just divide everything by 576. We're going to get the negative of the quantity x plus 2 squared over 144 plus y minus 7 quantity squared over 64 is equal to 1. We're going to switch this around just so this guy's out in front. So we have the quantity y minus 7 squared over 64 minus the quantity x plus 2 squared over 144 is equal to 1. So we know this would be a vertical hyperbola, right? The transverse axis would be vertical. All right, so coming down here, we're just going to match things up and then just sketch the graph. I'll just go through this pretty quickly. I've already pre-written things. So for a vertical hyperbola, we're going to have this form right here. So your h is going to be negative 2, and then your k is going to be positive 7. Remember, this is a minus and this is a plus, so you have to change that over. Your a squared is going to be 64, and your b squared is going to be 144. So c squared is equal to, again, a squared plus b squared, so that's 208. So a would be 8, b would be 12, and c would be 4 times the square root of 13. Remember, we're just using the principal square root for each of those. So coming down here, we're using the second row. The center is h comma k, so negative 2 comma 7, and you just plug in. So the vertices, we have negative 2 comma negative 1 and negative 2 comma 15. The co-vertices, negative 14 comma 7 and 10 comma 7. The foci, you have negative 2 comma 7 minus 4 times the square root of 13, and then negative 2 comma 7 plus 4 times the square root of 13. So this right here on the graph, you're going to see it approximated to about negative 7.4, let's just say 2. And this right here, if you approximate it, that's about 21.422. Okay, in terms of the asymptotes and the endpoints, again, we're going to use these formulas. And for the asymptotes, y equals, again, plus or minus a over b, times the quantity x minus h plus k, with h being negative 2, k being 7, a being 8, and b being 12. So when we plug things in, we get y equals plus or minus 2/3, times the quantity x plus 2, and then plus 7. So the 2/3 is coming from, if you look at 8 over 12, let me do that up here in case you're lost. So 8 over 12, if you divide 8 by 4, you're going to get 2. If you divide 12 by 4, you're going to get 3. So that's where the 2/3 is coming from. So splitting this up into cases, so y equals 2/3 times quantity x plus 2, then plus 7, you're going to get y equals 2/3 x plus 25/3. Then y equals negative 2/3 times the quantity x plus 2 plus 7. You're going to get y equals negative 2/3 x plus 17/3. In terms of the endpoints of the fundamental rectangle, you have 10 comma 15, negative 14 comma 15, 10 comma negative 1, and then negative 14 comma negative 1. All right, let's come down to the graph. So I think at this point, you would be able to pause the video and sketch this guy on your own, even if you didn't go through the parts where I gave you H, K, A, B, and C. Again, you should be able to get those on your own at this point. So this right here is your center. So that's negative 2 comma 7. Again, that's our H comma K. These are your vertices. So negative 2 comma 15, and then negative 2 comma negative 1. To get those, again, you use that definition of A. A is the distance from the center to each vertex. A here is 8, so I'm going 8 units up, and then 8 units down to get those vertices. When I talk about the co-vertices, they're going to be 10, 7, and then negative 14, 7. I use that definition of B being the distance from the center to each covertex. Your B here is 12, so I'm going from the center, 12 units to the right and 12 units to the left. So that's how I get those covertices. When I talk about the foci, again, this right here is an approximation, and so is this one. We covered that earlier. So this one is going to be negative 2, 21.422. So that's one of them. And then this one right here is negative 2, negative 7.422. So that's the other one. Again, the definition of C is that it's the distance from the center to each focus. So you're going up by 4 times the square root of 13, and you're going down by 4 times the square root of 13 to get the foci. In terms of the endpoints for the fundamental rectangle, again, when you think about B here, that's going to be involved in your horizontal movement, and A is going to be involved in your vertical movement. So I'm going B units to the right and A units up. Remember, B is 12 and A is 8. So starting at the center, if I go 12 units to the right and then 8 units up, I'm going to get this 10, 15. Then if I was to go 12 units to the left and 8 units up, I'm going to get this negative 14, 15. If I go 12 units to the left and then 8 units down, I'm going to get to this negative 14, negative 1. And then lastly, if I go 12 units to the right and then 8 units down, I'm going to be at this 10, negative 1. So those are your endpoints for the fundamental rectangle. And lastly, you have your asymptotes. So again, you can always use point slope form for that if you don't have that formula memorized, if you forget it for some reason. So this one right here, the equation will be y equals 2/3 x plus 25/3. This one that's negatively sloped, that's going to be y equals negative 2/3 x plus 17/3. If your teacher does not ask for the equations of the asymptotes, I would just make the fundamental rectangle and then extend the diagonals to get it if you're trying to make a quick sketch. So always just show your vertices, and then each branch is going to be drawn to where it approaches, but does not touch those asymptotes. So just like that. And let's do this one down here. And again, I left you a link on Desmos if you want to see this in more detail. All right, for problem 4, we are given negative x squared plus y squared plus 20x plus 8y minus 120 is equal to 0. Again, we're going to complete the square twice. So I'm going to group my x terms together and my y terms together. So I get negative x squared plus 20x coming from this guy and this guy, plus y squared plus 8y coming from this guy and this guy, minus 120 is equal to 0. So what you want to do is factor out the coefficient of x squared and y squared if it's not 1. So just the coefficient. Here it's a negative 1, so just pull out a negative. This becomes the negative of the quantity x squared minus 20x. And then plus, here you don't have to do anything because the coefficient is 1, so it's just y squared plus 8y. And then minus 120 is equal to 0. Okay, so completing the square, again, you're taking 1/2 of the coefficient of x raised to the first power, and you're squaring that. So you say negative 20 times 1/2, and then we're going to square that. So negative 20 times 1/2 is negative 10. So this is negative 10 squared, which is 100. So that's why we're adding and subtracting 100 inside the parentheses. So plus 100 and then minus 100. If you look at this h, which is the coefficient of y to the first power, we're going to do the same thing. Cut it in half and then square it. So 8 times 1/2 squared. 8 times 1/2 is 4. So this is 4 squared, which equals 16. So that's why we have this guy right here, which is plus 16 and then minus 16. When we think about the parentheses here, again, remember this negative is applied to every guy inside of there. So if you want to close this down, you need to distribute that negative to this negative 100. So basically negative 1 times negative 100 is plus 100. So that's where that comes from. And the parentheses slide down. Here, you have basically a 1 right there. So you could just slide the parentheses down with no impact. So you could just say this is negative 16. So if you do 100 minus 16 minus 120, you're going to get negative 36. And then if you add 36 to both sides, we end up with this negative of the quantity x squared minus 20x plus 100 plus the quantity y squared plus 8y plus 16 is equal to 36. All right, now we're going to factor each perfect square trinomial. So this is going to factor into x minus 10 quantity squared. Again, always look at half of this. Half of negative 20 is negative 10. That's where this is coming from. This is going to factor into y plus 4 quantity squared. Again, half of 8 is 4. So you end up with the negative of x minus 10 quantity squared plus y plus 4 quantity squared is equal to 36. Divide everything by 36 because you want the right side to be 1, and you get the quantity y plus 4 squared over 36 minus the quantity x minus 10 squared over 36 is equal to 1. All right, so let's come down here and match things up. So this is the form you want to use right here. We're going to say that our h value is 10, and our k value, again, this would need to be changed into a minus a negative 4. So your k is negative 4 there. Your a squared and your b squared are each going to be 36. So then c squared would be 36 plus 36, which is 72. So then a is 6, B is 6, and then C is 6 times the square root of 2. So we're going to be using this second row right here for the formulas. Again, H is 10, K is negative 4. So the center is H comma K, so 10 comma negative 4. And just plug into the formulas. Again, I did that to make it a little bit quicker for us. So we have 10 comma negative 10 and 10 comma 2 for the vertices. We have 4 comma negative 4 and 16 comma negative 4 for the covertices. The foci, you can have 10 comma negative 4 minus 6 times the square root of 2, and then 10 comma negative 4 plus 6 times the square root of 2. So let me do these with a calculator real quick, just so we know what we're going to have on the graph. So this one is about negative 12 point, let's say 485. Then this one is about 4.485. Again, in terms of the asymptotes in the fundamental rectangle, we're going to be using this second row right here. So for the asymptotes, we have y equals plus or minus a over b times the quantity x minus h plus k, where h is 10, k is negative 4, a is 6, and b is 6. So we know that 6 over 6 is 1. So really we just have, you could say plus or minus 1 out here, or you could just put plus or minus in front of the parentheses there. So y equals plus or minus, you'll say the quantity x minus 10, and then minus 4. Okay, so the first scenario, we can just drop the parentheses here. So y equals the quantity x minus 10 minus 4. Again, this is just a 1 right here, so you can just drop the parentheses. So this becomes y equals x minus 10 minus 4. So it's y equals x minus 14. Second scenario, you have the negative out in front of the parentheses. So you have to actually distribute that in. So y equals the negative of the quantity x minus 10 and then minus 4. If you simplify, you get y equals negative x plus 6. Endpoints for the fundamental rectangle, you're going to have 16 comma 2, 4 comma 2, 16 comma negative 10, and then 4 comma negative 10. Okay, let's come down here and look at the graph. So I'll just go through this one more quickly. Again, I think this is pretty straightforward at this point. The center we know is at 10 comma negative 4. So then we know A is 6 and B is 6. So again, from the center to each vertex is A units. From the center to each covertex is B units. So I'm going to go from the center up 6 units. That's 10 comma 2, that's my vertex. And then down 6 units, that's 10 comma negative 10, that's my other vertex. Then if I go from the center to the right by 6 units, I'm at 16 comma negative 4, that's my covertex. And then to the left by 6 units, that's 4 comma negative 4, that's my other covertex. In terms of the foci, again, we approximated this and this. So we're just going up by 6 times the square root of 2 from the center, and down by 6 times the square root of 2 from the center. So you get 10 comma 4.485, and you get 10 comma negative 12.485. So those are your foci. In terms of your asymptotes, again, we went through the formula for that. So you have y equals x minus 14, and then y equals negative x plus 6. You can always use point slope form if you want to derive those on your own. And then the endpoints of the fundamental rectangle, again, all I'm doing is I'm going from the center 6 units to the right and 6 units up. So that's 16 comma 2. From the center, 6 units to the left and 6 units up. So that's 4 comma 2. From the center, 6 units to the left and 6 units down. So that's 4 comma negative 10. And then from the center, 6 units to the right and 6 units down. So it's 16 comma negative 10. So once you have all that, again, here's your vertices right here. And then just sketch it to where each branch approaches, but does not touch those asymptotes. And I'm not the best drawer, even when I'm tracing. So this right here would look something like that. Again, you can always get the best picture. You would just click that link I gave you for Desmos. All right, for problem 5, we have 4x squared minus y squared plus 56x minus 4y plus 92 is equal to 0. So what I'm going to do is put my x guys together and my y guys together. So here I'm going to go 4x squared plus 56x. So that's coming from this guy and this guy. And then I'm going to go plus, I'm going to have negative y squared minus 4y. So that's this guy and then this guy. And then I'll just have my plus 92 and this equals 0. So of course you want to factor out the coefficient of your squared variable in each case if it's not 1. So here it's going to be 4, so pull that out. Here this is, you could say negative 1, so pull out this negative and put it out in front of the parentheses. So you get 4 times the quantity x squared plus 14x, then minus the quantity y squared plus 4y plus 92 is equal to 0. Now the next thing is we're going to complete the square. So we're going to look at the variable raised to the first power in each case. So you're going to have 14 and then 4. So again, you can do this in your head if you want. So 14 times a half is 7. 7 squared is going to be 49. And so this is plus 49 and minus 49 done there. And then for this one, if you cut 4 in half, 4 times a half is 2. And then you square it, 2 squared is 4. So you have plus 4 and then minus 4. Let me just show that real quick so nobody's lost. So this one was 14 times 1/2, and this is squared. And so this became 7 squared, which equals 49. Again, that's where we get this from. So you have plus 49 and then minus 49. And the other one real quick was 4 times 1/2. Again, that's going to be 2. And when we square this, 2 squared is obviously going to be 4. That's why we have plus 4 and then minus 4. Okay, so once we do that, what you have to do is slide the parentheses down. And remember that this 4 right here is being distributed to everything inside the parentheses. So if you're going to slide this down, you have to distribute the 4 to the negative 49. So in other words, 4 times negative 49 would be negative 196. Then this negative right here, again, is being applied to each guy inside the parentheses. Really what I would do to make this clear is you can go, this is plus negative 1 like that. And just think about negative 1 times negative 4, that's positive 4. So what we end up with, let me just highlight this times this is going to give me this plus 4 right there. So let me erase this. And the next step would be to add negative 196 plus 4 plus this 92 here, and you're going to get this negative 100 as a result. And then all we're going to end up doing is adding 100 to both sides of the equation, so you get this form right here, and then we're going to factor each perfect square trinomial. So this x squared plus 14x plus 49 is going to factor into x plus 7 quantity squared. Again, just take this guy right here and cut it in half. So 14 times a half is 7. That's why you have this x plus 7 quantity squared. Over here, y squared plus 4y plus 4. Again, cut 4 in half, you get 2. So you get y plus 2 quantity squared. So this would be 4 times the quantity x plus 7 squared minus the quantity y plus 2 squared is equal to 100. Now, at this point, you just want to make sure that the right side is 1. That's what you do for a hyperbola. So just divide everything by 100, and you're going to end up with a quantity x plus 7 squared over 25 minus the quantity y plus 2 squared over 100 is equal to 1. All right, let's set up our information for the graph. So this guy right here, you're going to match it to this form right here. So this is for a horizontal hyperbola with the center at h comma k. So your h here would be negative 7, and your k here would be negative 2. Again, because this is a plus, you want to change this to x minus a negative 7. Because this is a plus, you want to change that to y minus a negative 2. So once again, h is equal to negative 7 and k is equal to negative 2. Here your a squared would be 25 and your b squared would be 100, and then your c squared again is equal to a squared plus b squared, so that's 25 plus 100, which is 125. So then when you get a, that's going to be 5, again just the principal square root of 25, b is 10, that's the principal square root of 100, and then c is the principal square root of 125, which is going to be 5 times the square root of 5. All right, so coming down to our table, we're going to be working with this top row right here. We're just going to grab what we need. So we know the center is h comma k. H is negative 7, k is negative 2. So the center is negative 7 comma negative 2. And then we would just plug in to get our vertices, co-vertices, and foci. So for the vertices, you're going to get negative 12 comma negative 2, and then negative 2 comma negative 2. For the co-vertices, you're going to get negative 7 comma negative 12. And then negative 7 comma 8. And then for the foci, you have negative 7 minus 5 times square root of 5, comma negative 2, and then negative 7 plus 5 times square root of 5, comma negative 2. Let me go ahead and approximate these guys real quick because we're going to see it that way on the graph. So this right here, let's say it's about negative 18.18, and let me just say this is approximately. And this one, this is approximately, I punch that into the calculator, let's say it's about 4.18. So you're going to see those values on the graph. All right, so getting the asymptotes and the endpoints for the fundamental rectangle, you're going to be working with this top row right here. For the asymptotes, you have y equals plus or minus b over a times the quantity x minus h, and then plus k. H is negative 7, k is negative 2, a is 5, and b is 10. So if we do b over a, well, that's 10 over 5, which is 2. So y equals, this would be plus or minus 2 times the quantity x plus 7, and then you have minus 2. So the first scenario is where you have a positive 2 for the slope. So y equals 2 times the quantity x plus 7, and then minus 2. If you simplify, you get y equals 2x plus 12. The second scenario is where the slope is negative 2. So y equals negative 2 times the quantity x plus 7, and then minus 2. If you simplify, you get y equals negative 2x minus 16. And then for the endpoints of the fundamental rectangle, you're going to have negative 2 comma 8, negative 12 comma 8, negative 2 comma negative 12, and then negative 12 comma negative 12. All right, let's come down to the graph. So keep in mind that h is negative 7 and k is negative 2. So your center is, again, negative 7 comma negative 2. Your a value here is 5. So that means because this is a horizontal hyperbola, I'm going 5 units to the right and 5 units to the left from my center to get my vertices. So that one is negative 2 comma negative 2, and this one is negative 12 comma negative 2. Then my b value is 10. So that means from the center, I'm traveling 10 units up and 10 units down to get my co-vertices. So this one's negative 7 comma 8. This one's negative 7 comma negative 12. And then for the foci, again, the c value we found was 5 times square root of 5. So we're going to be traveling to the right by 5 times square root of 5 from the center. And you get this, let's say about 4.18 comma negative 2. We did that earlier in terms of approximating that. If we go from the center to the left by 5 times square root of 5, you're going to get this guy right here, which is about negative 18.18, and then comma negative 2. All right, let me erase all of these, and I'll just put my center back in. So let's just do the endpoints for the fundamental rectangle. Again, your A value is 5, your B value is 10. A here is going to be a horizontal movement. B here is going to be a vertical movement. So I'm going to go A units to the right and B units up. Again, A is 5, B is 10. So 5 units to the right, 10 units up. From that center, that's going to be right there, which is negative 2, 8. If I go 5 units to the left and then 10 units up, I'm going to be at negative 12, 8. If I go 5 units to the left and 10 units down, I'm going to be at negative 12, negative 12. If I go 5 units to the right and 10 units down, I'm going to be at negative 2, negative 12. So those are your endpoints for the fundamental rectangle. Again, you can always extend the diagonals from those if you want the asymptotes that way. Otherwise, you can use your formula that we saw in that table, or you can use point slope form if you need to. So this is the one that's positively sloped, so y equals 2x plus 12. Then this one is the one that's negatively sloped, and that's going to be y equals negative 2x minus 16. All right, once we have everything, I'm just going to highlight my vertices here and basically draw each branch once again to where it approaches those asymptotes but does not touch it. So that one, and let's do the same thing over here. Again, there's that link for you if you want to click on it, or Desmos if you want to see something that's computer generated and get more detail. All right, for problem 6, we have negative x squared plus 4y squared plus 2x minus 64y plus 239 is equal to 0. So with this one, again, we're going to combine our x terms together and our y terms together into different groups. So this right here is negative x squared plus 2x coming from this one and this one. This one is plus 4y squared minus 64y. That's coming from this one and this one. And then you just have your plus 239 is equal to 0. Okay, so again, we want to factor out any coefficient of the squared variables that we have that's not 1. So here it's basically negative 1 and here it's 4. So pull those out. So you get the negative of the quantity x squared minus 2x plus 4 times the quantity y squared minus 16y plus 239 is equal to 0. Okay, so here's where we're going to complete the square in each case. You're looking at this one and this one. So always the coefficient of the variable raised to the first power, cut it in half and square it. So negative 2 times a half is going to be negative 1. Square that, you get 1. That's why we have plus 1 and then minus 1. Negative 16 times a half is negative 8. Negative 8 squared is 64. So you have plus 64 and then minus 64. Again, when you want to close this down, you have to distribute the negative. So negative 1 times negative 1 is positive 1. So that's where that's coming from. And then 4 times negative 64 is negative 256. So that's where that's coming from. And then again, all you're going to do is add those numbers. So 1 minus 256 plus 239, that's going to give me that negative 16 right there. Let me actually highlight that because we added that too. So when we look at adding 16 to both sides, we get this form right here. And then all we're going to do is factor each perfect square trinomial. Again, when we cut this in half, we got negative 1. When we cut this in half, we got negative 8. So that's how we do our factoring. So this would be the negative of the quantity x minus 1 squared plus 4 times the quantity y minus 8 squared is equal to 16. Divide everything by 16 because we want the right side to be 1. And you get the negative of the quantity x minus 1 squared over 16 plus the quantity y minus 8 squared over 4 is equal to 1. And we're going to switch that around just to match our form. So we're going to end up with the quantity y minus 8 squared over 4 minus the quantity x minus 1 squared over 16 is equal to 1. Okay, so matching things up, this is the form we want to use. So your h is going to be 1 and your k is going to be 8. So that's pretty straightforward because this is a minus and this is a minus. This is a minus and this is a minus. So again, h is just 1 and k is just 8. A squared is 4 and b squared is going to be 16. So that means a is 2 and b is 4. And then again, c squared is going to be a squared plus b squared. So 4 plus 16 is 20. And if you take the principal square root of 20, you get 2 times square root of 5. So that's going to be your c. Okay, again, we're going to be working with this second row right here because the transverse axis is vertical. So your center is h comma k. So this is 1 comma 8. And then again, for a, b, and c, we have those values. So you can just plug into the formulas. So for the vertices, I have 1 comma 6 and then 1 comma 10. For the covertices, I have negative 3 comma 8 and 5 comma 8. For the foci, I have 1 comma 8 minus 2 times square root of 5 and then 1 comma 8 plus 2 times square root of 5. This right here is approximately 3.5, let's say 28. This right here is approximately, let's say 12.472. Again, we're going to use this second row right here for the formulas for the asymptotes and the endpoints of the fundamental rectangle. So the asymptotes, we have y equals plus or minus a over b times the quantity x minus h plus k. H is 1, k is 8, a is 2, and b is 4. If I'm plugging in here, 2 over 4 is 1/2. So you get y equals plus or minus 1/2 times the quantity x minus 1, then plus 8. So first scenario where this is positive, y equals 1/2 times the quantity x minus 1 plus 8. That's going to become y equals 1/2 x plus 15/2. Second scenario, we have y equals negative 1/2 times the quantity x minus 1, then plus 8. So that turns into y equals negative 1/2 x plus 17/2. Endpoints for the fundamental rectangle, you're going to have 5 comma 10, negative 3 comma 10, 5 comma 6, and then negative 3 comma 6. All right, let's just come down here to the graph. And I'm just going to write some things out just for reference. So we know that the h value is 1. The k value is 8. the a value, again, that's the principal square root of 4, that's 2. The b value, that's the principal square root of 16, that's going to be 4. Let me make that better. And then the c value, again, we found that earlier, that is 2 times square root of 5. But if you didn't have those formulas, again, just do a squared plus b squared. So that's 4 plus 16, that's 20. That would be c squared. So c squared, let me just write this out one more time, is equal to 20. And then just take the principal square root of 20 if you want c, and that's going to become 2 times square root of 5. All right, so our center is h comma k, so that's 1 comma 8 in this case. The a value is the distance from the center to each vertex. Because this is a vertical hyperbola and it's going to open up and down, we know we're traveling vertically to get to each vertex. In other words, from the center of 1 comma 8, I'm going to travel 2 units up to get to this vertex of 1 comma 10, and from that center I'm going to travel 2 units down to get to the other vertex of 1 comma 6. In terms of the covertices, now I'm going to use this b value. B is the distance from the center to each covertex. Here that's 4. Again, we would be moving horizontally here. So from the center, I'm moving 4 units to the right to get to this covertex, which is 5 comma 8. And then from the center, I'm moving 4 units to the left to get to this covertex, which is negative 3 comma 8. In terms of the foci, again, we use this c. That's the distance from the center to each focus. So from the center, we're going to go up by 2 times square root of 5. And we're going to go right there, which is 1 comma 12.472. Again, this is approximated from earlier. And then from the center, we're going to go down by 2 times square root of 5. And we're going to have this 1 comma 3.528. Again, that's approximated from earlier. So those are your foci. In terms of the endpoints for the fundamental rectangle, remember, because you have a vertical hyperbola, your a is involved with the vertical movement and your b is involved with the horizontal movement. So from the center, I'm going to go b units to the right and a units up. So b is 4 and a is 2. So in other words, from the center of 1 comma 8, I'm going 4 units to the right. So now my x coordinate would be 5, and 2 units up. So now my y coordinate would be 10. So I'm at that 5 comma 10. Then from the center, I'm going to go 4 units to the left and 2 units up. I'm going to be at negative 3 comma 10. From the center, I'm going to go 4 units to the left and then 2 units down. I'm going to be at negative 3 comma 6. And then lastly, from that center, I'm going to go 4 units to the right and then 2 units down. So I'm going to be at 5 comma 6. In terms of the asymptotes, again, you can always extend the diagonals from the fundamental rectangle that you just got, or you can use point slope form, or you could just plug into the formula. Again, lots of ways to do this. This guy right here that's positively sloped, we figured this out earlier. It's y equals 1/2 x plus 15 halves. This guy right here that is negatively sloped, this is y equals negative 1/2 x and then plus 17 halves. All right, so the last thing we're going to do here is just trace. So I'm just going to fill in these vertices, and I'm going to draw each branch to where it approaches, but does not touch those asymptotes. And let me do this one down here. Again, each branch is going to be drawn to approach, but not touch those asymptotes. All right, for problem 7, we are given vertices that are 7 comma 17, and then 7 comma 3, and then foci, which are 7 comma 10 plus the square root of 149, and then 7 comma 10 minus the square root of 149. So if we go back to our review, remember that this right here is the center. And right now it's at the origin. Again, you can shift it to some h comma k. This right here is your a comma 0, and this is your negative a comma 0. So if I think about the midpoint of this transverse axis, or the line segment, again, from negative a comma 0 to a comma 0, what is the midpoint right there? It's going to be 0 comma 0, or the center. In other words, if you did the midpoint formula, use capital M for that, that's equal to the average of the x coordinates, so a plus negative a is 0. And that would be divided by 2, which is still 0. And then comma, the average of the y coordinates, well, 0 plus 0 is 0, 0 divided by 2 is 0. So that's your midpoint, or the center. So we're just going to use that. And so here's our midpoint formula. Again, the average of the x coordinates and then the average of the y coordinates. So x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. So just use your vertices. Again, if you want to use the foci, that would work as well. Also, some problems will give you the covertices. You can use those as well. So for the vertices, again, you have 7 comma 17 and then 7 comma 3. So you could say that this is x sub 1, y sub 1, this is x sub 2, y sub 2. Again, the order doesn't really matter. So you're going to have 7 plus 7 over 2, which is going to be 14 over 2, which is still 7. And that should be obvious because this and this, those are not changing. So of course, the average of that is just going to be that itself. Then you have 17 plus 3, which is going to be 20 over 2, which is going to be 10. So the center would occur at 7 comma 10. Notice how the x coordinates did not change. So you're not moving horizontally, but the y coordinates did. So to get from one vertex to the other, you're moving vertically. So that means the transverse axis is vertical here. And so this guy's going to open up and down. So you have your center of 7 comma 10. So now you need to go through and figure out what are the denominators, so the a squared and then the b squared. So how you do that is up to you. Again, you just want to use the fact that the distance from the center to each vertex is a. So what I do is just pick it to where it's going to be positive. Again, you can do it to where it's going to be negative. Just make sure you use absolute value bars. So this is a vertex and this is a vertex. Again, I'm thinking about this vertically. Here's my y coordinate from the center, which is 10. Here's my y coordinate from the vertex, which is 17. So all you have to do is say 17 minus 10 is 7, because from the center to the vertex, I'm traveling 7 units up. So that means a is equal to 7 and a squared is 49. So if I build this up right now, I'm going to use y minus k, quantity squared, over a squared, and then minus x minus h, quantity squared, over b squared. Let me actually move this over. And let me get rid of this border, and I'll put it like this. So this equals 1. Well, what do I know? I know that k is 10, and I know that h is 7, and I know that a squared is going to be 49. So how do I get b squared? So remember that c squared is equal to a squared plus b squared. So how do we get c? Remember, c is the distance from the center to each focus. So if you have this 7, 10 plus square root of 149, and the center at 7, 10, well, again, all you have to do is take 10 plus the square root of 149 and then subtract away 10. That means I'm traveling from the center up by the square root of 149 to get to that focus right there. If I square the square root of 149, I'm just going to get 149. So c squared equals 149. Using the relationship c squared equals a squared plus b squared, you can rearrange this and say b squared is equal to, again, subtract a squared away from each side, so it's just c squared minus a squared. So c squared is 149 minus a squared, which is 49, so that equals 100. So b here would be equal to 10. So going back up, this right here would be 100. And you have your equation. Just putting things down in a neat way. Again, this is the form we're using. We know that h is going to be 7, k is going to be 10, a squared is 49, b squared is 100. So y minus 10 quantity squared over 49 minus x minus 7 quantity squared over 100 is equal to 1. So the covertices, again, we're just moving to the left by b units and to the right by b units. Remember, b is 10, so you can end up with negative 3, 10, and then 17, 10. And if you want your asymptotes, and again, endpoints for the fundamental rectangle, we're using the second row right here. So the asymptotes, again, y equals plus or minus a over b, times equal to x minus h plus k, where h is 7, k is 10, a is 7, and then b is 10. So if you do a over b, you're going to get 7/10. So y equals plus or minus 7/10 times equal to x minus 7, then plus 10. So when this is positive, you get y equals 7/10 times equal to x minus 7 plus 10. You simplify, you get y equals 7/10 x plus 51/10. Other scenario, y equals negative 7/10 times equal to x minus 7 plus 10. Simplify, you get y equals negative 7/10 x plus 149/10. Endpoints of the fundamental rectangle, you're going to get 17, 17, negative 3, 17, 17, 3, and then negative 3, 3. All right, so looking at the graph, we know the center is at 7, 10. We were given the vertices of 7, 17, and 7, 3. We were given the foci, and this is an approximation, and this is an approximation. So 7, 22.207, and then 7, negative 2.207. The covertices we figured out. Again, we're moving to the right by 10 units, and we're moving to the left by 10 units from the center. So you have 17, 10, and negative 3, 10. For the asymptotes, again, we plugged into the formula. You can always use the points of the formula line if you need to. So y equals 7/10 x plus 51/10. That's this one, and this one is negatively sloped, so y equals negative 7/10 x plus 149/10. In terms of the endpoints for the fundamental rectangle, from the center, you're going to the right by 10 units and then up by 7, so that's your 17, 7. You're going to the left by 10 units and then up by 7 units, so negative 3, 17. From the center, you're going to the left by 10 units and down by 7 units, so negative 3, 3. And then from the center, you're going to the right by 10 units and then down by 7 units, so 17, 3. In terms of drawing this guy, again, here's your vertex and here's your vertex. So we'll just sketch this like this, and that like that. And then this one right here would sketch like this, and this like this. So again, each branch is going to be drawn to where it approaches the asymptotes, but they don't touch. All right, for problem 8, we are given vertices that are 21, negative 9, and then negative 3, negative 9, and then foci, which are 24, negative 9, and then negative 6, negative 9. Again, you can use the midpoint formula with either one of those. I'm just going to use the vertices. So just plug in. You're going to have the average of the x coordinates and then the average of the y coordinates. Notice that the y coordinate in each case is negative 9. It's not changing. So to get from one vertex to the other, you are traveling horizontally. So that means the transverse axis will be horizontal. This guy's going to open to the left and to the right. So just plugging in, let's just do 21 plus negative 3. That's going to be 18. 18 over 2 is 9. And of course, this will be negative 9, but you could do it here. So negative 9 plus negative 9 is negative 18. Divided by 2 is negative 9. So the center is 9, negative 9. then when you think about your a squared and your b squared, just go back to the definition. So we know that a is the distance from the center to each vertex. So I'm just going to, again, just take this x coordinate here of 21 and subtract away this x coordinate here of 9. You could also do it with this if you want, but you have to do it inside of absolute value bars. So you do 21 minus 9, you're going to get 12. If you do it the other way, because people often ask me about this, would it work? Well, yeah, it would. You could just do -3 minus 9 like that inside of absolute value bars. So this is equal to the absolute value of -12, which is positive 12. So just make sure that if it's not going to be a positive result, just put it inside of absolute value bars so that you get a positive result, because a is a distance. So we know that a is 12, and of course a squared would be 12 squared, which is 144. Then in terms of getting b squared, you really need to get c squared, and again, you use your definition. It's the distance from the center to each focus. You can use this focus right here, which is 24 comma -9, and just do 24 minus 9, which is 15. Of course, if you wanted to do -6 minus 9 like that, make sure you do it inside of absolute value bars. You get the absolute value of -15, which is 15. So it's the same either way. I just always go with the one that's going to make it positive. That way it's easier. So c squared would be equal to 15 squared, which is 225. You have b squared is equal to c squared minus a squared. So that's 225 minus 144, which is 81. So b squared is 81, and then b is 9. So if we put everything together, h is 9, k is -9, a squared is 144, b squared is 81. You get x minus 9 quantity squared over 144 minus y plus 9 quantity squared over 81 is equal to 1. So for the covertices, again, because the transverse axis is horizontal here, the conjugate axis is going to be vertical. So you're traveling up by b units and down by b units from the center. We get 9 comma -18 and then 9 comma 0. With the asymptotes and then the endpoints of the fundamental rectangle, again, we're going to be using this top row right here. So the asymptotes, we have y equals plus or minus b over a times the quantity x minus h plus k. So h is 9, k is -9, a is 12, and b is 9. So if we have b over a, that is 9 over 12. Divide this by 3, you get 3. Divide this by 3, you get 4. So that's going to simplify to 3/4. So you're going to get y equals plus or minus 3/4 times the quantity x minus 9, and then minus 9. First case where it's positive, y equals 3/4 times the quantity x minus 9, then minus 9. So we simplify, we get y equals 3/4 x minus 63/4. Second case where it's negative, y equals -3/4 times the quantity x minus 9, then minus 9. So you get y equals -3/4 x minus 9/4. All right, the endpoints for the fundamental rectangle, you've got 21 comma 0, -3 comma 0, 21 comma -18, and then -3 comma -18. All right, coming down to the graph, we were given the vertices, so 21 comma -9, and then -3 comma -9. You were given your foci, so 24 comma -9, and then -6 comma -9. We were not given the covertices, so 9 comma 0 and 9 comma -18. Again, you use b for that, and b is 9. So you're traveling up by 9 units from the center to get to 9 comma 0, and down by 9 units from the center to get to 9 comma -18. Then in terms of your asymptotes, again, we did those with the formula. You can always use point slope form if you want. You have y equals 3/4 x minus 63/4. And then this one is negatively sloped, so y equals -3/4 x minus 9/4. The endpoints for the fundamental rectangle, you're going to start at the center and go to the right by 12 units, and then go up by 9 units, so that's 21 comma 0. Starting at the center, you're going to go to the left by 12 units and then up by 9 units, so that's -3 comma 0. From the center, you're going to go to the left by 12 units and then down by 9 units, so -3 comma -18. And then from the center, you're going to go to the right by 12 units and then down by 9 units, so 21 comma -18. In terms of sketching the graph, here's your vertex, here's another vertex, and again, each branch is going to approach, but not touch those asymptotes. So something like that. All right, for problem 9, we are given vertices that are 19 comma -4, and then -5 comma -4, and then foci, which are 20 comma -4, and then -6 comma -4. So I'm going to use my midpoint formula with the vertices. If you want to use the foci, that's going to be up to you. Again, we want to find the average of the x coordinates, and then comma, the average of the y coordinates. So just plugging in, you're going to have 19 plus -5. That's going to be 14. 14 over 2 is 7. And then for this one, you have the same y coordinate in each case, so it's just going to be that guy. So it's just -4, right? So -4 plus -4 is -8. Divide by 2, you get -4. Now, because the x coordinates are different here, you know that the transverse axis is horizontal, because if you're traveling from one vertex to the other, you're moving horizontally. All right, so in terms of finding a, again, the distance from the center to each vertex is a. So you can just take this vertex right here, and you could just say this x coordinate minus this x coordinate, so 19 minus 7 would be 12. So a is 12, and so a squared is 144. Again, if we're trying to find c, well, c is the distance from the center to each focus. So you can use this x coordinate minus this x coordinate. So 20 minus 7 would be 13. So c squared is 13 squared, which is 169. So b squared equals c squared minus a squared. So it's 169 minus 144, which is 25, which makes b equal to 5. Putting everything together, our h is 7, our k is -4. So again, minus the -4 is +4. Our a squared is 144, and our b squared is 25. So we have the quantity x minus 7 squared over 144 minus the quantity y plus 4 squared over 25 is equal to 1. Co-vertices, you're going to have 7 comma negative 9 and then 7 comma 1. And then to get the asymptotes and the endpoints of the fundamental rectangle, we're going to use this top row right here. So for the asymptotes, we're going to have y equals plus or minus b over a times the quantity x minus h plus k, where h is 7, k is negative 4, a is 12, and b is 5. So we get y equals plus or minus 5 over 12 times the quantity x minus 7 minus 4. So the first one where this is positive, y equals 5/12 times the quantity x minus 7, then minus 4. You simplify, you get y equals 5/12 x minus 83/12. The second one where it's negative, y equals negative 5/12 times the quantity x minus 7 minus 4. You're going to get y equals negative 5/12 x minus 13/12 after you simplify. And then the endpoints for the fundamental rectangle, you're going to get 19 comma 1, negative 5 comma 1, 19 comma negative 9, and negative 5 comma negative 9. All right, in terms of the graph here, it's going to be a little bit distorted because of the scale of things. Again, I left you a link on Desmos if you want to click that. But you'll see that horizontally, the scale is in terms of 2. So 2, 4, 6, 8. And then vertically, it's in terms of 1. So 1, 2, 3, 4. So that's going to mess with the graph a little bit. But I had to do that to fit it on the screen. So if we look at the h comma k, or the center, that's 7 comma negative 4. And again, we were given the vertices of 19 comma negative 4 and then negative 5 comma negative 4. I was given the foci of 20 comma negative 4 and then negative 6 comma negative 4. When we think about the co-vertices, those were not given. You're using that b value of 5. So we're going up by 5 units and down by 5 units from the center. So we get 7 comma 1 and 7 comma negative 9. And then in terms of the asymptotes, again, we used our formula. You can always use point-slope form if you need to. So this is y equals 5/12 x minus 83/12. This guy right here. This one's negatively sloped. So it's y equals negative 5/12 x minus 13/12. And then if you want the endpoints for the fundamental rectangle, you're going to, from the center, go to the right by 12 units and go up by 5 units. So that's 19 comma 1. Then from the center, you're going to go to the left by 12 units and up by 5 units. So that's your negative 5 comma 1. You're going to go from the center to the left by 12 units and down by 5 units. So that's negative 5 comma negative 9. And then from the center, you're going to go to the right by 12 units and then down by 5 units. So that's 19 comma negative 9. In terms of sketching the sky, when you draw each branch, it's going to approach but not touch the asymptotes. So something like that. Maybe that one could be better. So let me try to trace that a little bit better like that. And then this one, something like that. And then something like that. All right, for problem 10, we were given vertices that are negative 4 comma 21, and then negative 4 comma negative 9, and then foci, which are negative 4 comma 23, and then negative 4 comma negative 11. So just plugging into the midpoint formula to get the center. Again, this is negative 4 and this is negative 4. The x coordinates are not changing. So it's just going to be negative 4 for the x coordinate of the center or the h value. Again, you can always just do negative 4 plus negative 4, which is negative 8 divided by 2, which is negative 4. It's another way to do it. Then the y coordinates are changing. So you have 21 plus negative 9. That's going to be 12. And then 12 divided by 2 is 6. So that's your y coordinate. Because this y coordinate is different from this y coordinate, again, when we move from one vertex to the other, we're moving vertically. So the transverse axis is vertical. In terms of getting the a value here, this is the same and this is the same. I want to work with the y coordinates. I'm going to do 21 minus 6. So 21 minus 6 is 15. 15 squared is 225. So a squared is 225. Then in terms of getting b squared, remember we want to get c squared first. So that's the distance from the center to each focus. Again, these x coordinates are the same. So you're going to work with this y coordinate and this y coordinate. So 23 minus 6 is 17. So 17 squared is 289. So c squared is 289. When we look at b squared, it's equal to c squared minus a squared. So 289 minus 225, that's 64. So then b is going to be equal to 8. So just plugging into this form right here, again, this is going to be for the transverse axis being vertical. H is negative 4, k is 6, a squared is 225, and b squared is 64. So we get y minus 6 quantity squared over 225 minus x plus 4 quantity squared over 64 is equal to 1. The co-vertices are going to get negative 12 comma 6, and then 4 comma 6 if you just plug in. In terms of getting the asymptotes and the endpoints for the fundamental rectangle, you're using the bottom row right here. So the asymptotes, you have y equals plus or minus a over b times the quantity x minus h plus k. Your h is negative 4, your k is 6, your a is 15, and your b is 8. So you get y equals plus or minus 15 over 8 times the quantity x plus 4, then plus 6. First case where this is positive, y equals 15/8 times the quantity x plus 4, then plus 6. You simplify, you get y equals 15/8 x plus 27/2. Second case where this is negative, y equals negative 15/8 times the quantity x plus 4 plus 6. You simplify here, you get y equals negative 15/8 times x minus 3/2. The endpoints for the fundamental rectangle, you have 4 comma 21, negative 12 comma 21, 4 comma negative 9, and then negative 12 comma negative 9. So coming down here to the graph, again, we were given the vertices of negative 4 comma 21 and negative 4 comma negative 9. Our foci were also given to us, so negative 4 comma 23, and then negative 4 comma negative 11. The co-vertices were not given, but again, we just use our formula. We know that b here is is going to be 8. That's the principal square root of 64. So you're going to go to the right by 8 units and to the left by 8 units. And you're going to have 4 comma 6 and then negative 12 comma 6. So those are your co-vertices. In terms of your asymptotes, again, we got those from the formula. Y equals 15/8 x plus 27 halves. So that's this one that's positively sloped. The one that's negatively sloped, that's going to be y equals negative 15/8 x minus 3 halves. The endpoints of the fundamental rectangle, again, you're going to go from the center to the right by 8 units and then up by 15 units. So this is 4 comma 21. Then from the center to the left by 8 units and then up by 15 units. So that's negative 12 comma 21. And then from the center, you're going to the left by 8 units and then down by 15 units. So this is negative 12 comma negative 9. And then from the center, you're going to the right by 8 units and then down by 15 units. So this is 4 comma negative 9. In terms of graphing this guy, so here's my vertex and here's another vertex. And I'm just going to draw this to where each branch approaches but does not touch the asymptotes. Same thing over here. So approaches but does not touch the asymptotes. And that part is not too good. So let's do it again. And I think that's close enough. So again, you can click that link on Desmos if you want to look at this guy in more detail. The scale of this thing is going to make the graph a little bit distorted. So it will look a little bit different on Desmos. And that's because this guy right here is in terms of 2. So it's 2, 4, 6, 8. And this guy right here is in terms of 1. So 1, 2, 3, 4. So just click the link on Desmos if you want to see it over there.